Please like and leave a heart, please.
There we go. Hello, everybody, and welcome to the Vidor Locksmith Show. I'm your host, David Gibson, where we are unlocking the secrets to success in the oil and gas industry, one interview, one technical presentation, one technical screw-up at a time. Guys, please let me know if the audio and everything is working. I know last week I had a bit of an echo. I think there was an extra button pushed here on my little, I don't know what you call it, my little switcher or whatnot. So hopefully everything's working right. Please let me know where you guys are watching from. Love to be able to give anyone and everyone a shout out here on the show. I know we've already got a handful of people in the comment section right now. Hopefully everybody's had a wonderful week. We've got an amazing show lined up for you today. This individual, Jason Norman, is somebody who actually prior to this morning, never met before, never really interacted with, but had seen a lot of his content that he was putting out on LinkedIn, a lot of educational content, very technical as well. So I figured this is an excellent platform to be able to have Jason come on and be able to be a part of the show and be able to, kind of put the message out there for all of us to be able to learn a little something today. So like I said, hopefully everybody's having a wonderful week. If you guys would, just let me know where you're watching from. Try to think of anything else that was going on this week. Not much that I could think of. I know ADIPEC's coming up very soon. We got the SBATCE in about a month. So if you guys are going to be in the San Antonio area, please put that on your calendar to be able to come out and attend. All right. So we've already got Eric tuning in from sunny south of France. As per normal, says hello, Jason and Dave. Mr. John DeWar says good morning from National Park of Speed Road America, Elkhart Lake. Vintage race weekend is underway. 300 cars. Not gonna lie, sounds like a lot of fun to me. I am one that is partial to race cars. A little bit of conversation going on back there in the comment section. Then James C says tuned in from Midland, Texas. Robert tuned in from Houston, Texas says audio is great. Thank you, sir. I do appreciate that. Always helps out. Eric says I've been waiting for this show for a while now. All right, well there we go. LinkedIn Junior says good morning. Audio is working for us. Signing in from Houston. All right, excellent. All right, guys. Well, I guess we only got a handful of people wanting to shout out. Oh, well, here we go. Mohammed says he's tuning in from Arlington, Texas. There we go. Where I used to go to school at. All right, guys. If you want to, be sure to put in hashtag Gibson to be able to win yourself a drill bit. We're going to be giving away another one of these here this week. Jeff just says, morning from Houston. Audio good. Need more rain. Completely agree. Completely agree. Cannot deny the need for more rain. Right. So if you guys will type in hashtag Gibson into the comment section now, we'll get you guys a chance to be able to win one of these fantastical drill bits. Can't guarantee it'll be the yellow one. Might be one of the other random colors that we've got in there. But if you put in hashtag Gibson, you get yourself entered to win a drill bit. While we're doing that, got a quick little intro video here for the How It's Done show. If you haven't seen it, there's a whole series. We've got season 1. We're halfway through season 2, waiting on some approvals from some of the companies that are participating in season 2. And so here is the intro. If this intro doesn't get you jazzed up to watch some oil and gas stuff, then nothing else will. Love it. Every time I see it, just makes me giddy. To miss the 12 and a quarter. We've never made a 12 and a quarter. We've made 8.5, but not a 12 and a quarter yet. Pattern's not big enough for the 12 and a quarter. I think 8.5 is as big as it will go. Actually, no, I might be able to make a 12 and a quarter. It might be able to, but that would take probably 2 or 3 weeks to print. All right. Back to the show stuff. All right. So, like I said, we've got an amazing guest here joining us today. We'll do the drawing for the bit a little bit later. So if you guys are, while you guys are watching, feel free to be able to put in. All right, on today's show, we've got here Jason Norman. Jason, thanks for being on the show today.
Thank you. Hello, everyone.
Well, Jason, normally I would say I know your background and I kind of know a little bit about you, but the audience doesn't. But I'm part of the audience today. So why don't you give us a little bit of your background and what you're going to be talking to us about today?
All right. So Jason Norman, I've been a mud engineer for 20 plus years. I got a master's degree in petroleum engineering. I've been the technical director for new technology for Absmart for the past 4 years. I'm also one of the principal owners. And, I'd like to just put it out there right away is that we're not drilling fluids experts, right? We have a passion for real-time drilling fluids data and process control. I surround myself with drilling fluids experts. But what I am is a subject matter expert in performance optimization, right? We have a radical vision for holistically connecting drill solids to all other workflows on the rig, right? We believe that the drill solids are the culprit to many of the NPT and ILT events that we see. And I'd like to dig into this and I'll show you what I see.
All right. You want me to go ahead and add your presentation up?
Sure.
All right, here we go.
So I just, that was my spiel for the first slide. You can go right to the second one.
Oh, okay. There we go.
So in the spirit of the 1 hour time slot, I gave you 6 discussion topics. Each one of them could be an hour long easily, but I digested things down so that we can talk about sensor technologies, where we came from to where we are, right? Some of the software development differentiators that we've applied, we know we have a unique deliverable, and I'll explain to you how we got there. What makes drill solids removal so important? I'll show you 25 reasons why drill solids removal is important. There's this new element of ESG compliance and greenhouse gas emissions that we're seeing. It's a hot topic, and it plugs right into what we're doing here, right? A lot of drilling fluid, rig topography nuances that I'd like to just get into a few of those because I think it's important for other folks playing in this space to understand what they're up against when they start measuring drilling fluid properties. And then I got a little piece on industry perception and adoption, right? So that's where we'll go. Next slide.
Excellent. Oh, there we go.
So I didn't want it to be a marketing ploy or anything like that, but I did want to put a couple of pictures of the latest solutions that we've come up with. And I can go back a little bit and talk about, where all this came from. So years ago, we've tried it all, right? We've tried the skid mounted version. We've tried the trailer mounted version. We've tried, big Coriolis meters in the flow line and on the suction line. And what we've landed on is that while those solutions are very they have good data quality, the client would prefer a slim down, small footprint, easy to move, no real issues with doing a rig move or a rig skid. And where we landed is some of these technologies are very simple, right? Bernoulli's pressure differential, tried and true, 300 years. We can measure density using pressure differential. We can measure percent water, percent oil, which we use to calculate our low gravity solids, high gravity solids. We use a capacitance sensor for that. For all of our diesel and water, totalizers. We use a conventional turbine flow meter, very simple. And for our centrifuge applications, for our effluent and suction on the centrifuge side, we use Coriolis. So the idea of slimming things down and integrating into the rig, that's what's important, right? So the more that we can put sensors and have them integrated holistically into the rig design, that would be the ultimate solution, right? So from a drilling contractor perspective, building the sensors into the rig design itself and do the upfront pre-planning, that's the ultimate route to go. For us, at this 10 seconds, we're looking at an adoption period. So we have to be able to do it the way we're doing it until we get those buy-in from the forward thinkers that we're hoping are going to dial in due time. And we have been getting some good feedback from drilling contractors. So I expect it's going to happen in due time. It'll just become a standard package on every rig. You know, one of the things that I did want to point out here is over the years, we've tested probably 75 to 100 different sensors.
Wow.
And we, at the beginning, when we didn't understand what we were doing, we threw out perfectly good ideas, or at least I believe we threw out perfectly good ideas. And what I mean by that is the sensor technologies, when we first started playing and we didn't understand all these little nuances to the drilling fluid, we'd put a sensor out, we'd try to get it to measure, we would fail, we would junk it as failed attempt, and then we move on to the next sensor. Well, what we realized and what we discovered is that these nuances, you can engineer out the nuance, and you can then start working with the data, work with the firmware, and get sensors to measure properly under many different conditions. So for example, you got, fluid going in and out of the well. Well, you got pressure, you got compressibility, blah, 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 all these things that you need to be able to compensate for. You got large cuttings coming down the flow line. So some sensors are going to work better in some environments than others. So my point to that long-windedness is don't throw out your ideas on the first attempt. I think I made a post on LinkedIn one day where I said, if you're going to go out and test something, make the plan to test it in multiple places. Don't just go out and stick it in the active pit, end up with a failed attempt, and then write it off as it's not going to work. Try it on the centrifuge suction line. Try it on the line going to the frac tanks. What you'll discover is somewhere along the way, there's a sensor specifically suitable for a perfect application, right? Next slide. So this is a high-level version of what we do today, right? So if you got a process control diagram and you got frac tanks, you got all these things going on. You got mud moving to and from the frac tanks, going in and out of the well, going in and out of the solids control equipment. You're adding base oil and water dilution. And what do we do today? 1 to 2 mud checks a day on land jobs, maybe 4 mud checks on an offshore rig. And the only other parameter we're measuring in the backyard is pit volumes. So the next slide basically says, all right, well, in a process controlled environment, where can we place sensors strategically to give us the maximum data? And what I mean by that is when you have data in multiple places, it's easier to do to make inferences. So you don't need to measure everything. You can measure here, measure there, and calculate what's going. For example, what's going in and out of a centrifuge. You can calculate what's going down the slide, right, as a waste stream. You don't need to measure it, right, using a material balance. And I'll get into that on the next go around. But to me, if we're going to look at drilling holes in the ground from a proactive perspective, that 1 or 2 mud checks a day is not going to keep up with the 300 to 400 feet an hour rates of penetration that we're currently doing. We're going to need all this data. We're going to need everything in order to achieve that technical limit. So one of the things I wrote for a note, I made the comment that all this data is necessary, right? If you want to optimize hydraulics, if you want to optimize trip speed monitoring, if you want to optimize hole cleaning or you name whatever calculations that you're currently doing using static data, when you start plugging real-time data into some of these models, you're going to see a drastically different result. You're going to see things that you've never seen before. You know, and one of the analogies that I use is, you know, if you use the analogy that you have a Formula One race car, right? And you got millions of dollars at risk, and we choose to measure the performance of that car using a handheld device only when the driver pulls in for a pit stop to get his tires checked, right? So my point to that is, you know, we have this $1 million machine running out there. Actually, it's not a million, it's tens of millions. And we got a well that's of highest importance, and we need data to ensure or to reduce risk. That's the whole point to this, is to reduce the risk. And, you know, sensors, in my opinion, are 10 times cheaper than the problems associated to what can be mitigated, right? So if you take a stuck pipe incident or, you know, well control, you know, if it gets out of hand, you know, $100,000 sensor is almost meaningless to a project that you've just had a major issue. Next slide.
Yes, sir.
So we've spent a lot of time working on software, right? And we felt like we didn't need to spend any time on hydraulics. We didn't need to spend any time on trip speed monitoring. We didn't need to, somebody else has already got that perfected. But the gap that we've seen in our space is the backyard. I can't find any piece of software on this planet that looks at it holistically from a material mass balance, using first principles, right? The conservation of mass, right? All we needed was mass, volume, and density, right? And we're able to do a whole host of things that we believe are important. And at the end of the day, if you got the 2 key performance indicators that we think has the most value, is you got a hole cleaning efficiency, you're going to drill fast, you're going to create all these cuttings. So now you got to get them out of the well, right? Equally important is, well, now that you got all those cuttings out of the well, you got to get them out of the mud. And by doing a material mass balance, we can tell you what's going back, what we're pumping back down the well. We can tell you what is coming out of the well. We can tell you then what your solids removal efficiency is at surface based on your dilution, how much product you're adding, how much waste is going out as a waste stream, right? So
Jason, to interrupt real quick, why do you think it is that this is like there's that gap there? Like you said, there's stuff that talk about trip speeds, there's stuff that talks about torque and drag, and, you know, tons of other software. Why do you think that this portion of the industry has been ignored?
It's an education thing. I don't think that drilling engineers, drilling contractors, downhole tool guys know what exactly is destroying their rig, what exactly is destroying their downhole tools, what, you know, drilling performance guys are looking at their the data that's provided to them, and there's likely not a good answer, except that lack of education. We ignore drill solids. It's the last thing on the rig that anybody pays attention to. You know, there's a little misconceptions out there. I can give you one basic example. You know, you'll find that company men will say, well, if I run my centrifuge, I'm going to be throwing away barite. Well, that's a rebuttal. Obviously, you're going to throw away barite. You're going to throw away some diesel, but nothing compares to the volume of drill solids that you're going to remove by running your centrifuge. So I think it just needs time, and we believe the next phase to all this is empirical data. Keep putting empirical data in front of folks and show them that they're actually losing, you know, 27 barrels of diesel, you know, 17 tons of barite, but, you know, 75 barrels of drill solids has been removed from the system. And because you're removing all these solids from the system, now you're seeing it downstream in your drilling performance. You're seeing it in your diesel consumption through your generators. You're seeing it in the higher rate of penetration, all because you're removing drill solids. Did that answer it anywhere near close to what you were looking for?
I mean, any answer is better than what I know as of right now, because I'm in the group of the uneducated portion of the industry. Eric here says we need more professionals educated in systems thinking.
There you go.
So, all right, I'll let you keep going.
Did
you lose your train of thought?
So I got a little note here saying that, you know, this is not about the volume of solids removed. This is about the volume of solids not removed, right? So when that fluid goes down the pipe and it picks up all those cuttings off the bottom of at the bit, and they start going north. So problem one is how much of these solids are not getting removed from the well. That's what's causing all of your drilling performance issues, like rate of penetration, slower, directional control is worse. So you got this porpoising going on with your directional tools. So then let's just say 20% of those solids that make it back to surface don't get removed at the shakers. And now you're pumping them back down the well. So all we're doing is compounding now the problem at the bit by continually to drill fast, continue to add more drill cuttings to that annular space, but we're adding this volume of solids that's being pumped back down the well to compound our problem, right? So it's got everything to do with the solids that are not removed, right, on that first pass. And this is the education piece that I think we're missing is we put a lot of effort into designing the well, but then when it comes time to put the solids control equipment in place, everybody goes on the cheap, right? Everybody just says, well, I just need one centrifuge because I'm only running it an hour a day. And we're okay with those crappy shakers that got holes in the rubbers and the springs are broken and et cetera. All the things that's why a shale shaker is inefficient. So I think that's it, right? The mindset has to change at the planning level so that folks know that the highest priority should be to get those solids out on the very first pass, not to pump solids back down the well, only to compound the problem when it comes back on the second round. Because that grind, you get into horizontal, and all those cuttings that are being conveyed along the horizontal are now sitting on the low side of the hole, and they're getting harder and harder to remove, right? So now when you start getting into cementing operations, and you know, I remember last week I was watching you had George King on, and he was talking about the porpoising and how on the production side, after that well has been completed, and now they bring on production and they get this slugging effect. Well, I'm not going to say that it's a 100% contributor, but if you got on the low side of the hole, you got all these cuttings, the cuttings bed buildup, and couple it with poor directional control. Of course, when you run casing in there in the production string, you're going to have this porpoise. You're going to have these the low points are going to collect the gas, and now the slugging problem is getting worse. So it all gets tied together, right? Everything that we're doing seems to get tied back to drill solids, and it's time for us all to start thinking about it. How can we mitigate it, right? How can we solve these problems before the problem happens? Right. So another note here is talking about, I'll get into it on another slide as well, but there's a huge component of low gravity solids that is quartz, right? And the quartz content is the part that's causing the damage, right? The erosion of the high pressure lines on the rig. I can get into it more on the next one of the next slides here, right? So from a software development perspective, this compositional material mass balance is a unique approach, right? And it encapsulates all that is good in drilling fluids management, right? So the material balance gets us to a place where, and I might add, we tried to keep it simple, right? This is first principles. This is not digital twin yet. This is not AI driven, right? This is just pure math. It says mass, volume, and density. Here's what's going in and out of your mud system. And we can quantify how much rock you generated, how much rock you removed, how much solids is still in your mud, how much waste is going out as a waste stream. What's the performance of your centrifuge, right? Are you at maximum efficiency? And all of that is, in my opinion, simple, right? Anybody can do it. It took us a while, we've been 10 years doing this, but it's not magic, and it's not anything really that proprietary. It's just pure math, right? Next slide.
Sir.
So, like I said, we have two components, right? We got two KPIs, sorry. We got the solids removal efficiency at surface, and we got the solids removal efficiency in the hole, or hole cleaning efficiency. And what we've done is we've created this algorithm, and we have a few assumptions, obviously. And what we've done is we said, all right, if we know what we're generating in the active mud pit, we know what our low gravity solids are, we know what our density is, we know what our flow. We can calculate the mass flow of water, the mass flow of oil, the mass flow of high gravity solids, the mass flow of low gravity solids. And if you follow it all the way through the process, and you do the necessary compensations due to the material balance for gas compensation, compressibility, etc., right? Porosity, permeability, get into the details all along that path of fluid going down the pipe, picking up the drill cuttings, bringing them back to surface. We can track this all the way along. And we got a few assumptions, like I said, that we have to abide by. And no doubt it will, the more we work with it, the more we'll get, it'll start to tweak, and we'll be able to get better. But at the end of the day, conventionally, we've always used pressure, right? If you look at any of these conventional methods, right? Cuttings carrying index, or cuttings concentration in the annulus, the annular velocity versus cuttings slip velocity, cuttings transport ratio, equivalent circulating density, your torque and drag, pick up, slack off. All of these are all based off of pressure and rheology, right? Or pressure and hydraulics. And what we're doing is saying, all right, well, let's just couple the material balance, or cross-reference, if you will, the material balance against conventional methods. And now you got one that can help you validate the other, right? In the hole in real time. So a lot going on that slide. I know if anybody wants to talk about any of this stuff, I can do a deep dive at any time. So just reach out and
well, we've got a question here from Henry. And he says, all these calculations mentioned, material mass balance, mass volume density, is directly related to the actual size of the hole being drilled. I still see some companies using planned hole size or drill bit size for those calculations, which in turn defeats the purpose. What is the best approach for this?
Interesting question, right? So Victor spent eons working on these formulas. And what we did is we built an upper and lower limit on our ranges for several of the assumptions, right? And when you got porosity at 15% versus 20%, or I'm trying to think off the top of my head now, but there were several there that when you make a change to many of the assumptions from a lower to upper limit, the end result was very small, like say 1% on the hole cleaning efficiency output to go from the lower limit to the upper limit, until you get to hole size. The biggest contributor to a hole cleaning algorithm is the hole size. And what is your percent washout, right? And we don't have a good answer except occasionally run a caliper sweep, right? You can always, do those carbide or rice bombs just to get a general idea. How long did it take for that sweep to go all the way around? And then just back calculate that tells you that, well, obviously it was 3 minutes late, therefore it must be 6% open hole volume, open hole enlargement. I don't know of any other way at this 10 seconds, but a good question, because it is the biggest contributor to a hole cleaning algorithm in using mass balance.
Have you guys ever done any like retrospective look where you're doing the stuff in real time and you're working on it, but then afterwards had a caliper run and then be able to use that information, whether it was run in while they were drilling or done after the fact in kind of a post drilling process, to be able to kind of validate some of the numbers, or to be able to give you some sort of relationship?
Absolutely. The answer is no. The next job, we actually sent our guys to the field here on Monday of this week. So we're doing an install on the newest job, and this latest algorithm is getting rolled out on that job. So check back with me in 3 weeks' time, and I'll tell you if the caliper, assuming we can get one, does help us with this algorithm, because I'm pretty sure it will. Once you can see what exactly you got, the math is going to make way more sense, right? Rather than guess at it. Right now, we just call it 6%, even though a lot of clients say they have no washout. But we also got clients that tell us that they don't have any fluid loss to the formation. And, we know the difference of that, right? So one of the comments that I made in my notes on this slide was, just for clarity, right? Drill solids, LGS, low gravity solids, ultrafines, colloidals, all mean the same thing. So sometimes we get in conversations with people and people are unclear as to what exactly are we talking about here. Low gravity solids are drill solids, ultrafines, colloidals. They all mean the same, right? So it's the same mass of solids that's not being removed that can cause all the drilling performance issues that we see.
Taking some notes here. Good stuff.
Next slide.
Yes, sir.
So why should we remove more drill solids? What exactly does drill solids touch, right, throughout the day, right? So obviously we got drilling performance, right? ROP, MSE, D exponent, torque and drag, hole cleaning, cuttings carrying index. All these things that can affect drilling performance is impacted by the concentration of solids in the mud, right? Well documented, right? It impacts your fluid rheological profile, right? Which then in turn impacts all your drilling performance numbers, right? We got this root cause analysis portion that came into our funnel here just recently in the past couple months, where, you know, drilling contractors and downhole tool folks would like to have some sort of a paper trail that shows them what's going on with the mud in relation to my downhole tool failure, for example. So having this paper trail of measuring low gravity solids in real time could certainly help the cause for those guys needing to understand what exactly is tearing up their motors, right? So if you look at equipment wear and erosion, right? So the drilling contractors got a huge, big problem here where on the high pressure lines, the mud pump consumables, charge pump impellers, valves, all of these things are getting worn out because of solids. And my opinion, it's specifically the quartz that's causing all the grief here, right? And one of the things I wanted to note is that barite by itself in the silo, if you grabbed a sample of it, right, it can contain as much as 20% low gravity solids right out of the silo, right? And then when you test that with XRF technology and actually
what's XRF?
X-ray diffraction.
Okay.
Right? It measures, we can quantify the amount of quartz that's in a barite sample, and we've seen it at 10 to 15% pure quartz is in a barite sample. So I'm not saying that every single sample out there that you go to the silo today and you're going to get these high quartz contents. But I just wanted to make everybody aware that we're adding quartz to the mud system every day. If you add 100 tons of barite in a 10-day well, right, rest assured that you're somewhere in the 10 tons of quartz that you're adding to your mud system. So, and to top it off, there's no real spec behind this, right? There's no API spec on barite quality surrounding quartz content. So it's not like you're out of spec for having 10% by weight quartz, right? It's perfectly acceptable. So my point to this whole thing is that you got these drill solids that were circulating around and around the well. We're carrying, you know, all these drill solids from well to well, right? And what we do is we try to make sense out of what's going on. What we use particle size distribution, we use quartz content, we use low gravity solids, and we try to make sense out of what's actually going on out there, and is there any room for improvement, right? And we can see a few things, right? Like centrifuge utilization is one thing that's easy to see. All you got to do is put a Coriolis meter and add up the number of minutes that there was actual flow going through the Coriolis. Will tell you how much use did the Coriolis get, or the centrifuge actually get. So when we see 20% utilization, right, against the available utilization. So if you had 20 hours of drilling and you only ran the centrifuge for an hour, we know it. And the question you have to ask yourself is why? Why are you not running it for the whole time? Pumps are pumping, centrifuge running. It's not. These are the sorts of things that we can see and we can advise on, right? We don't really have any authority to tell them what to do, but we can certainly recommend what they can do to help make things better. Next slide. Are we
Sir.
good for time? I got like 4 more to go, I think.
I've got all day, so
All right.
don't
So
bother me.
the next place, and Eric will be happy with this one, right? So I started paying attention to the number of truckloads of waste, right, going from the rig to the waste management facility. And I started tracking them and adding them up, right? And I assigned a gallons per or miles per gallon, sorry, on a typical diesel pusher. And I came up with estimated CO2 emissions from waste hauling. And then you can do the same thing for product hauling, right? So if you're hauling barite and lime and salt, and these products are getting brought from the warehouse to the rig, it too also is burning diesel, which is emitting CO2, right? You got the diesel generators themselves that's producing the energy on the rig, right? So as that mud system is loaded up with drill solids, the diesel generator is working harder, therefore it requires more diesel. And you got trucks emitting diesel that's bringing the diesel to feed the generator, but you're also emitting diesel from the diesel generator. So you start adding up all these points of contact where we are emitting CO2. And then you look at, what I did is I took a stretch target. I said, if you got a client that has 5 rigs running, and each rig is able to generate X amount of tons of CO2 per year, and we're able to make a stretch target, say, of 20%. We just shave off 20% across the board in savings, right? In efficiencies, or in making things better. Then here's the amount of CO2 that we could save, right? So the carbon credits that you could achieve from using or emitting less greenhouse gas, right? So one of the things that I just recently got with Eric on is this Scope 3 greenhouse gas emission reporting. It means that they can claim carbon credits for greenhouse gas emissions that went into the producing of that lime or that salt, that emulsifier, that diesel, right? And if they can demonstrate that they've used less of it, then they can capture it. And that rule of thumb right now is a 1-to-1, meaning if it's about 1 ton of greenhouse gas for every ton of product produced. So it's just a number. There's a lot more investigating needs to be done here, but I wanted to make folks aware that there's a lot of holisticness to this whole process of drill solids and why we want to remove them, because across the board it seems to touch multiple different places in the value chain and the well delivery process. Next slide.
Yes, sir.
So one of the things that I can do for a technology transfer, if you will, right? So we've been doing this a long time, and we broke a lot of things along the way, right? And we
continue to break a lot of things along the way.
And we continue to break a lot of things along the way. But at the end of the day, every time we break something, we learn something, right? And these little nuances that I talk about is getting to the right answer, right? Mathematically, using physics, math, science, whatever word you want to use for it. We compensate for gas, we compensate for fluid compressibility, agitation in the pits, right? We see pressure drop differences due to mud pumps and mixed pumps being on or off. And all of these things will affect your data, right? Fluid temperature, square bottom tanks versus round bottom tanks, full pipes versus partially filled pipes, high shear versus low shear, right? All of these things, I can give people an insight as to when you're out there trying to get data out of a sensor and you can't figure out why I can't get the same result as what the mud engineer or what the derrickman gets, there's a reason for it, right? And in order to get to the high value, high quality data, you have to understand these subtle nuances first, right? Now, fortunately, like I said here, a lot of years working in this space allowed us to uncover most of these nuances. A perfect example is the derrickman, right? He grabs his 1 liter sample from the top of the tank. Sensors are at the bottom of the tank, right? And there's several nuances that would result in that mud balance density output to be different from the sensor output, right? One, for example, is bubbles liberating out of the mud, right? Something as simple as that. All of a sudden, the derrickman's got a low density measurement, sensor's got a high density measurement, right? And there's many, 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 many more of those little reasons why I guess you gotta take it with a grain of salt. I think in one of my slides, the last slide, maybe it's the next slide, right? It is the next slide. Go to the next slide.
Okay.
Right. So the perception then, when you got a derrickman grabbing a sample and that mud sample doesn't end up being the same as what the sensor is reading, the first thing he's going to do is say, well, if it doesn't match, it's perceived as being incorrect or not accurate, right? So my answer to that is, remember, we don't have a lot to work with here, right? The conventional instrumentation, like a mud balance or a retort or a fan 35, these are old, antiquated technologies, right? And we had to do things like this TEV analysis, for example, right? Is this total equipment variance. If you go to any other industry and when they're measuring their process control sensors against their lab equipment, the first thing they do is they do a statistical analysis on what the actual accuracy is of the reference data, right? So when we ran the TEV analysis on the mud balance and the retort and the fan 35, that sort of thing, we came up with like 5, 7, a 10 mil retort can have 9% error, right? So my point is, when we're out there in the field, be cognizant that the reference data that you're comparing to, which is a mud balance or a 10 mil retort or a fan 35, has its inherent error. So you got to be cognizant that don't throw out the sensor right away. There's likely there's nothing wrong with it. Your problem is the reference data you're using to calibrate it, right? So the other piece that we talk about is this volume piece, right? So you got the derrickman grabs a 1 liter sample. It's a 2,500 barrel system, it's like chalk and cheese, right? You got the sensor is measuring the entire system and you're grabbing 1 aliquot from a 2,500 barrel system. So one of the things I put in the joke, right, that, the joke amongst ourselves is that we hear the field guys say, yeah, your sensors are pretty close to what the derrickman got, right? Meanwhile, we've compensated for gas and for fluid compressibility and mud pump pressure draw from the pumps and the aeration from the hopper and bubbles liberating out of the mud and temperature to get to our number, right? That's the same as what the derrickman is reading. So it's an interesting little joke amongst ourselves, right? So another point that I wanted to make on this slide, right, from an industry perception, right? So when we got our operators, they run a field trial on any one specific measurement solution. I'll just use rheology or density or flow, right? Once that trial period is concluded and all the parties compile their data, right? If the analysis results in not being high enough or not being able to identify enough tangible value to justify the cost of the equipment, then we're usually left with a tainted client. And what that means is it could take years to get a drilling engineer or a drilling manager back on the horse and try the next new development, because he's now had this feeling that he tried something, it failed because he couldn't get the value out of it, right? So there's a perception that, you know, in my opinion, right, we need to look beyond the tangible, right? We got to get in and focus on behaviors that are limiting these efficiencies, right? You know, drill solids removal, in my opinion, is a choice, right, that can turn into a problem, right? We like to get the root cause. We like to find the culprit, make the necessary engineering changes, right? And then we mitigate the issue. We no longer have a technical barrier here. What we have is largely a behavioral one. Right? Last slide.
Yes, sir.
So final thoughts, right? Drilling fluids instrumentation, right? New technology has always been slow adoption in the drilling industry. We know there are technologies available that can deliver multiple parameters from one low-cost solution. We need time to develop and obviously the cash flow to sustain that growth, right? And we understand the reluctance to spend heavily in this space, right? But the bottom line is that the industry needs to be better. It needs lower cost solutions, right? In order to meet these budgets on U.S. land markets, we think that U.S. land stands to gain the most because it has the largest gap, right? So the final thought is that if drilling fluids instrumentation, right, in this space had the same CapEx investment as what's been spent on downhole tool development, we'd already be measuring a full mud check from one instrument going in and out of the well, and everything we need to know would be captured. Just think about that. The amount of money spent on new drill bit technology, new mud motor technologies. There's been, I wouldn't even be able to come up with a number. You probably got a better number in your head that how much industry has spent on downhole improvements, and just look at how little has been spent on surface drilling fluids, instrumentation, software, etc. That's where we are today, guys. That's it. We have some good ideas. What we need now is lots more willing participants. Let us go out and show you what we can do.
Well, we've got a lot of great comments that are coming into the comment section, so I want to throw a couple of these out here before we get too far behind on it. So John asked a question: what is the general consensus on what continent has the most focus on real-time sensor management?
Good question. It was just the other day I had a meeting with my colleague, and we were talking about the Middle East. And you know, while the Middle East is a little bit harder to get your foot in the door, once you're in the door, it's usually a longer term contract and probably a good place for us to target next. So I don't know if that answered it, John, but the Middle East seems like a hot spot right now. There's a lot of discussion coming out of Middle East, and they are open to new technology and new technology development.
And this one went back to, you know, I didn't interrupt you at the time, but it says very true. The oil field viscometer and retorts are horrible for this. There could be as much as a 20% variance in both.
Absolutely. And it's the big problem, right? Because of the perception piece. People, it is what it is. If they believe that that retort is the right number, if we show up and do something different and we get 20% low gravity solids, but what's on the report is 10% low gravity solids, it's going to be a discussion.
And to that point, Todd says, at the end of the day, the sensor can provide trend data, even if the results are not identical to the Mudman, since the sensor probably makes a reading every 3 to 5 minutes real time, a mudman's check is always 3 to 4 hours behind.
Yeah, good point. Just for the record, we have 1 second data. We got a retort update every second.
And then John says, Jason, the time to develop uncertainty models for vintage mud sensors to demonstrate their inaccuracy.
Absolutely. This is where this TEV analysis comes in. I'll probably do some work with you, John, on that. I'll share with you what I use, and when you see it, you can maybe help me see if we can get it in to the right audience.
And this one, John also says, it all comes down to sample size. The bigger the sample, the more accurate your prediction will be.
There you go.
I'm not sure who this one's from. LinkedIn user plotted trends from sensors compared to damages and or performance. So
the last big field study we did, I put it in my end report that the next phase to this is to start plotting tool failures, how many hours on that run, how many hours on swabs, liners, etc., and start plotting, low gravity solids, particle size distribution, quartz content against the failure, and start generating some sort of a feedback loop that says we can use it for predictive failure analysis, so that maybe you've TD'd the well, that mud pump liner is about to go in the next 4 hours because of the predictive nature of the algorithm. Maybe you'll do it while you're tripping rather than doing it, waiting for it to fail when you get back on bottom, as an example.
So 2 more interesting comments here. We've got one from Robert S. that says, Jason, good observation. Focus on the behavior. And then very similar to that, very important to agree on what success looks like when doing field tests.
Absolutely.
We've still got more vibers. And so just a handful more comments in there. Anything else you would like to be able to, kind of share with the audience here, Jason?
I think I've said everything that I can think of. It's entrepreneurialism is a interesting beast, right? In a slow-moving slug environment, it's challenging. I got 10 or 12 years of my life now put into this, and I only see one option, and that is press on, keep going until it breaks over. And, we're getting one job at a time, and that's essentially what we're doing. One job at a time. And so anybody wants to do anything in the drilling fluids instrumentation space, or you're thinking about doing some trials on something, even if it's in flow loop testing, call me. I mean, we're wide open to collaborating with anybody that sees the vision.
Excellent. Well, Jason, thanks so much for coming on to the show. One last thing we got to do here today is give away a drill bit. We'll throw this up on the screen. We had 17 people be able to enter in. I'll give everybody another shot to be able to put in hashtag Gibson if they won't, even though there is a slight delay in there. So John DeWar says, keep calm and carry on.
Thank you, John.
Very true. All right. So let me go ahead and see here. We'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And yep, 17 people entered in. All right, let's see who is the winner for this week. Get yourself a pretty drill bit. We'll get this sent off to you pretty quick. Let's see. And Robert. Robert, you are the winner this week. Thanks so much for watching the show, sir. Shoot me a message over on LinkedIn. I'll get Tracy, or shoot me your address or whatnot, and then we'll get you one of these drill bits sent off. Thanks for tuning in, sir. And then we even have my coach here. It says Joel. It says awesome. And then John DeWar says great show. Thanks to Jason for the valuable insights. Somebody put in just a little too late, but that's all right. And then it says great presentation. Thank you guys all so much for watching. Do appreciate it. We're gonna do some quick little announcements here real quick. I'll take that off the screen. So next week, we've got Vasily, who is going to tell us about designing drill bits. He's going to be on the show next week, and that will be episode number 150. The following week, I'll be doing a Brazilian Jiu-Jitsu competition, so it won't be live on the 29th. And then we're coming back with Andy Wood, who's going to talk to us about pretty much just geothermal stuff, right? Still lining somebody up for the 13th. And then after that, the ever-present Mr. Mike Barignac is going to be talking to us about oilfield sales. How to be a sales guy in the oilfield industry. All right, that's our show for this week. Thank you guys all so much for watching. Do appreciate it. Tune in next week. We'll be giving away probably something a little bit more special than just one drill bit. Maybe even have a sponsor for next week's show. So tune in. Look forward to seeing you guys all next week. Have a wonderful weekend. And as always, know your industry.
Thank you, sir.
Yes, sir.
Thanks, everyone.